All right, so here is Notes Unit 4.1 for my Honors Algebra 2 course. If I sound like I'm going kind of fast through this, sorry. I actually just recorded the whole thing and then I pushed the wrong button and I didn't save it. So, oh well. So the objective is going to be able to graph base, be able to graph parabolas in standard form. In class, we went over that there is actually 3 forms that we're going to be going over in class. So we're starting off with what's called standard form. So let's go ahead and get to that since we took a lot of these notes in class. Main parts of the parabola, axis or line of symmetry is this green line that basically splits your graph into 2 symmetrical parts. Vertex is the highest or lowest point when it's a function, and part of our work today is we're going to find an extra point. And it turns out when you have 1 point on one side of the axis of symmetry, then the distance that this point is away from the axis of symmetry, you can go the same distance on this side, and then you'll end up with a identical, well, reflected point basically over this line. So you get, I think in class I said it's like a 2-for-1 deal. When you get 1 point, you actually get a second one automatically by just seeing how far it is. In my class, I'm going to have you guys find 3 points. Other classes, you might be asked to find more than 3, but in my class, you just find the vertex, an extra point. It could be any extra point, and then reflect it over the axis of symmetry to get your symmetric point. But the other one's called the symmetric point. By the way, the symmetric point's not always on the left. If you found the point on this side and then found reflected it over this way, this one will be the symmetric point. It all depends on which one you find first. All right, parent graph, we'll go over that. We went over that. Standard form looks like this, vertex form looks like this, intercept form looks like this. We're focusing on this one. We went over a little bit about why these two are helpful also, but let's focus on this one. So the steps that we're going to be taking here are we're going to find the vertex. After that, we're going to identify 1 extra point, use the axis of symmetry to find a symmetric point, and then sketch the parabola. So graphing in standard form, first step over there, they said find the vertex. Vertex is an actual point, so it's x comma y. We're going to find the x value of that point using this right here. So basically what you're going to do is you're going to find your a, whatever number is in front of x squared, find your b, whatever number is in front of x, plug it in here, that'll get you your x value. Now, just like with any point, once you have an x value, that's your input, you can put it into your equation and then you'll get an output of a y, and then put your y right here and you'll have your vertex, x comma y. So for example, if x was a -6, you'd put -6 in here, put a -6 in here, a, b, and c will be numbers, and then you just evaluate that and you'll get your y. So after you get your x, plug it back into the original equation, I just said that, and then you'll get your y value back out. Now that'll get you your vertex. Now the next part was to find an extra point. So to find an extra point, you're going to pick another x value. Try to pick an x value that's near the x value of your vertex. So if the x value of your vertex, say, is a 3, you might want to pick a 2 for your x value of your next point. Or you might want to pick a 4. So either one number bigger or one number smaller than the x value of your vertex. Plug it in to the original, and you get your y value out, you'll get another point. Now the y-intercept is actually the easiest one to find. Reason being is that to find a y-intercept, you have to plug a 0 in for x. So if you put a 0 in for x into a standard form equation, 0 squared will always be 0. And then times a, whatever number a is, 0 times any number is still going to be 0. So this whole thing turns into a 0. Plus, same thing happens here, that turns into a 0 plus c. So let's say c was a 5. This would be 0 plus 5. So it'd just be 5. Your y-intercept will be 5. Basically what I'm getting at is that when it's in standard form, this c value is your y-intercept. That's a very easy extra point to find. It's not always the most efficient one to use though, and I'll show you why later. So after you get that extra point, you're going to use the axis of symmetry or line of symmetry. It's called both of those things. To get another point, which is called your symmetric point, and then after that, you would draw a smooth curve. Yay! That's the point of doing all of this, is drawing a smooth curve. Try to make it as smooth as possible. We only deal with smooth curves here. So vertex, so basically this is what's going to happen. First, you're going to find your vertex using those steps I said. So let's say that was our vertex. Next step, we do need an axis of symmetry. So you should be drawing an axis of symmetry through your vertex right when you get it, or a little bit after. So there you go. We got our vertex. We know our vertex is on our line of symmetry. There you go. Now, next thing is we're going to pick an x value close to our vertex, and let's say that we end up with a point, I don't know, like right here. Now, since we know it's a parabola, since we're dealing with quadratics, you actually have half of your parabola, because you have to start at your vertex and go to the other point. Now, what we're going to do next is you would figure out how far is this point from this axis of symmetry, and then you would go the exact same distance over here. So let's say this was like 2 away here, so I'd go 2 this way, and then my other point would be, looks like it'd be about right there. And then you would draw your line. And there you go. That's basically what we're going to be doing today. All right, let's do a first example. So graph the following, identify a vertex, an extra point, and a symmetric point. So let's go ahead and put these off to the side right now. And then we'll fill them in as we get them. So vertex is a point. The extra point, we'll just call it EP for extra point. That's another point. And then our symmetric point is right there. Okay, so once we find all those things, basically that's answering the question. But we got to graph it still. So first off is our vertex. Now we know it has to deal with A, B, and C, so we should figure out that first. A is 1, B is a -6, C is a 2. Oops. Your A value is always in front of your x squared, so there's always a 1 right here. If there is not a number written there, then you're going to assume there's a 1 there. So that's called our quadratic term because it has a squared. Our B term is a -6 because that's our linear term. This is called the linear term because it's just an x. And then this is called our constant. That's the part with no x. And the formula we're going to use for our vertex is x equals -b over 2a. So this will be negative blank spot over 2 blank spot. The blank spots will be filled in with a b on the top. Our b is a -6, an a on the bottom, and a is a 1. So -6 is a +6 over a 2, which is a 3. Okay, so that's your vertex, x part of your vertex. So we went ahead and took the 3, put it in there. We have our x part. So the y part, what we're going to do is we're going to take this 3, plug it back into our original equation, and then we'll have our y part of our vertex. So I'm going to go ahead and put the blank spots in right now. So y equals x squared minus 6x plus a 2. And the number that's going to go inside of there is 3. Reason is because that was the 3 right there. So that's going in there and there. Okay, so 3 squared is a 9. -18 plus a 2. 9 minus 18 is a -9 plus 2 is a -7. And there you go. That's your y value. So y value is a -7. So we have our vertex, extra point. Now the extra point we said, or I said, I want it to be near the vertex right here. So the extra point, it helps maybe if you make your XY chart. So that's your input output. For the input, so I know when I put in a 3, I got out a -7. So my next value I want to pick is by the 3. So what number is by 3? So it could be either a 4 or a 2. Either one is fine, doesn't really matter. I'm going to go ahead and pick a 2 because it's smaller computations that I'd have to do. So that will be plugged into our original equation. That'll be 2 squared minus 6 times 2 plus 2. That's going to be a 4 minus 6, 12 plus a 2. 4 minus 12 is a -8 plus 2 is a -6. All right. So when I plug in a 2, let me double check that. 6, 12, -8 plus 2 is a -6. Okay. So my extra point, I got 2 comma -6. All I did is I picked another x value. I tried to make sure it was close to my vertex and then got it out, another y value. Now, I won't know my symmetric point until I start graphing. So let's go ahead and start graphing. All right, so vertex is at 3, -7. So I'm going to go right 3 and down 7. Right, 3 down, 1, 2, 3, 4, 5, 6, 7. All right, I'm going to go ahead and make my line of symmetry. And there you go. So I have my vertex. I drew my line of symmetry through. That way I know that that's the part that breaks it into two pieces that are symmetrical. I'm going to plot my point 2, -6. So right 2, down 1, 2, 3, 4, 5, 6. Okay. So 2, -6 is right here. Now I actually have half of my graph right here. Um, Now, using the axis of symmetry, I know that this is 1 unit away from my line of symmetry. That means I'm going to go 1 more unit this way, and then that will give me my symmetric point. Okay, let me round this off a little more. And that's going to go up that way. And there you go. You have your graph. The symmetric point looks like it's at, let's see here, 1, 2, 3, 4. So the x value is a 4. And then I went down to -6 again. And there you go. Now, the part I was saying before was that you could have picked another value to plug in instead of 2. The easier value to plug in would have been 0. Because if you plug a 0 in for x, you get a y-intercept. So 0 squared is 0, 6 times 0 is 0, you get a 2. So you would have actually got a point of 0, comma 2. And that does count as an extra point instead of using this 2 right here. But the problem with that would be, let's say that we didn't plot this point right here. We wouldn't have got that point right there. So we'd have the vertex, and our next point would have been at 0, 2. 0, 2 is way up here. So you would have had to draw from this point, like way up here. And it looks like I drew it kind of well because it's actually going up there. But I mean, it's a longer way to graph, so it's a little more difficult in the way that your graph might look a little bit more sloppy. But I mean, that's up to you. You could actually do 1 extra point and then do another y-intercept. I mean, the more points, the more accurate, right? Right? Like you're listening to me. 1, 2, 3 this way. So we're gonna go 1, 2, 3 this way. So that would have been your symmetric point right here. And it does look like that if I kept extending my parabola out, I would actually hit those 2 points. All right. So that's how you do these. So find your x value, plug it in, get your y value out for your vertex, find an extra point that's near your vertex, or your y-intercept is okay too. It's just up to how far apart those are. And then that's about it. On your, oops, why did I do that? So that's the graph. Let me rearrange these. On your homework, you do have some problems that look like this. It says something like y equals 2x squared plus 5 or something like that. If there's a missing part, a is in front of your x squared, b is in front of your x. You don't have an x, so b is a 0, and then c is a 5. So if there are missing parts like that, you would just fill those in and then figure it out from there. It's like 1/3 x squared. A is a 1/3. B is a 0. C is a 0. Just do the exact same steps, but you're going to be just using zeros, which is pretty easy to calculate actually. And that's it. So try out your homeworks. Bring me questions tomorrow. Hey, look, only 13 minutes, so that's great. Okay, talk to you guys tomorrow, for some of you, most of you, if you're not absent. Okay, bye-bye.